In synthetic aperture radar, or SAR, images, ships, planes, and oil tankers aren't just pixels. They're complex patterns shaped by electromagnetic waves, noise, and interference. And when deep learning models like CNNs spot them, how they see matters, especially in military and disaster response applications. But here's the problem: CNNs are black boxes. We train them, they classify, but we don't know why. That's where visual explanation comes in. Most methods like Grad-CAM or SCORE-CAM work great on optical images, but fail on SAR. Why? SAR's speckle noise, phase information, and unique contrast make standard attention maps blurry, incomplete, or even misleading. Enter MSCAM, multi-weight self-matching class activation mapping. This new method doesn't just use one kind of weight, it combines element-wise weights, which measure spatial importance at each pixel, and channel-wise weights, which track which features matter most. Then it matches the input SAR image directly with the feature maps, a technique called self-matching, to preserve fine details like a ship's bow or a tanker's pipeline. The result? Sharper, more accurate heat maps that cover entire targets, not just patches. And crucially, it works even in shallow layers, where models first detect edges and textures. We tested it on a custom SAR dataset with 4,000 images of ships and aircraft. MSCAM outperformed Grad-CAM, self-matching CAM, and even the newer Grad-CAM++. It reduced background noise, captured structural details, and stayed consistent across layers. And here's the kicker. We used MSCAM for weakly supervised object localization, meaning no bounding box labels. Just a class label. The model generated a saliency map, applied a threshold, and drew a bounding box. It worked, but only if the threshold was tuned. Too low, you get background. Too high, you miss parts of the target. So future work. Dynamic thresholding, adapting the cutoff per image. Bottom line, MSCAM gives us a clearer window into how CNNs see the world, especially in radar, where every pixel counts. This isn't just about making models explainable. It's about making them trustworthy. And in high-stakes remote sensing, that's everything.